Okay, so y'all looked really good on that, all right? So long division. Long division, by the way, is one of those things. I was talking with someone this morning that once you get the hang of it, it's really, really easy. But if you were to go show someone, look what I can do, we should look really, really smart. Right? It looks very complicated. So to get started here, we put, what goes under here, the long gobbledygook or the short divisor? Right, the long gobbledygook goes under here. And then the divisor goes out front. Remember, you're starting with the first terms each time. And here's how I like to think about it to myself when I'm working. I ask myself, x times what would give me x cubed? And I answer myself, x squared, and I write that here above this x squared. Okay? Because my mind likes that process better. But maybe you like thinking about it more of like a division problem. Instead of me, I'm trying to think about it as a multiplication. But remember, those are inverses of each other. If you like division, you could do this on the side of your paper. You could take this leading term, x cubed, divided by that leading term, x, and it will give you the same thing. Okay, that's really what you're trying to figure out. So then once you have that up here, you multiply it by everything in the divisor and bring it down. So that gives me x cubed plus 2x squared. That's going to be subtracted off. Which of those things am I subtracting? Both of them. So I need to change the sign on both. So that will look like this. This becomes negative and this becomes negative, which the x cubes drop out then, and I have 1x squared here. And I bring down the next term. Okay, and now the process starts all over again. So but this is like just, we're done with the x squared. When I say the process starts all over, we're forgetting everything we did here, and now we're thinking about this as our beginning, the x squared minus the 4x. This is my leading term now. And so I say, okay, x times what will give me x squared? It's x. If you wanted to do it as a ratio of terms, you would take this one divided by the x, and that would give you x. Either way, it's still x. So then you take that x, multiply by your divisor, the x plus 2. So that's x squared plus 2x. Subtract those off, which means they both get a sign change. That gives me negative 6x. Bring down the last term, which is negative 12. Now my leading term here is negative 6x. X times what gives me that? Negative 6. Or if you're doing a ratio, it looks like this. Okay. Negative 6 times the divisor. But when you change the signs, boom, boom, they both cancel out and you have a remainder of 0. And you can handle that remainder one of two ways. I like to just not even consider it. I like to just write my quotient and be done. Or if you just want to keep that general form with the remainder over the divisor, because you like that consistency and it doesn't feel like it's messing with your mind, you can write like this, 0 over x plus 2. Okay, so whichever you like. All right, so who got that correct? All right, perfect. What I'm going to do is I'll answer any homework questions you have, but we're going to use this exact same problem as a lead into today's lesson. Today we're doing synthetic division, which I think you will like. Does anybody need this up anymore? Are there homework questions? Yes? Yes. 33? Okay. What can I help you with? You're good? Okay. Anyone else? All right. No? Yes? Right here? For sure, never mind? Okay. Because I could try harder if you want me to. Okay. Did I do 2 different 2s? Like I actually wrote the 2s differently? So like if this was CSI, you couldn't tell if I was the murderer or not? Because I signed all my stuff differently? Oh, good for me. I need to start killing some people. Oh, on the warm-up? Where did I do that? I have no idea. Like sometimes it's kind of curvy and sometimes it's flat, you mean?
No, like look, the x to the third plus 2x squared.
I don't know.
Do you not see it?
No.
It's like really long.
I don't know what you're talking about.
Do you see 3x squared?
Okay, 3x squared.
The first one. They're down.
Here?
Yeah, that one.
This too?
Yeah.
It's big?
No, they're different.
Because it's like a flat bottom and this one's a curvy bottom?
Yes, then you did other, like you.
I think I did twos different all the way around. I guess my mood changes in the middle of the poem. Like from one thing to the other. Okay, sorry. All right. This is interesting information. Let's. Thank you. Actually, we put it on my desk for me. Yeah, my desk. Oh no. So we're learning synthetic division today. It's a more efficient way of doing division, getting the exact same answer we did yesterday with long division. In fact, you're going to ask me, or it's going to occur to you at the end, well, why did we even learn long division in the first place? Well, here's the thing. Synthetic division is only for linear divisors. So that means you're dividing by something that has a degree of 1. Once you're dividing by an x squared plus 5 or an x cubed minus 2x or whatever, the synthetic division doesn't work. So it's only for linear. If your divisor ends up being nonlinear, you need to go back to long division. All right. And here's how that's going to work for us. This third statement right here, it's very heavy on the vocabulary. I'll explain it all to you. But it's saying that synthetic division uses the zero or root of the divisor and the coefficients of the dividend. So here's what that means. This was what our warm-up problem looked like. Let me write it back up here. X cubed plus blah, 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 et cetera, so forth. Blah, blah, blah. Gosh, I recorded that too. Okay. When I'm talking about the zero or root of the divisor, first of all, what's the divisor? The long thing or the short thing? The short thing. Okay, so the short thing is x plus 2. What do you think is the zero or root of x plus 2? Negative 2. It's whatever makes that thing equal 0. So the zero of this is negative 2. And I'll show you what we're going to do with that here in a bit. And then when I say we're going to use the coefficients of the dividend, this long thing is the dividend. And the coefficients are the numbers in front of the variables. Okay? So for example, the x cubed right here really has a 1 in front. What's the coefficient on this next term? This next one? And the next one? Negative 12, right? So we're going to use these for synthetic division. And if you notice that very first example on your notes, it's the same problem from the warm-up, which we did with long division, and now we're going to do synthetic. We already know what the answer is going to look like, so we'll be able to draw parallels between the two methods. So here's how it goes. We're going to take the zero of the divisor. Thank you. The zero of the divisor, which was negative 2, and we're going to put it in this little box like that. Okay? And then we're going to take all the coefficients of the dividend and write those next to it. So it's 1, 3, negative 4, negative 12. Now this is a process that will repeat itself. It'll become quicker, but maybe with just your eyeballs for a moment. Don't write anything. Don't look on your paper. Just sort of look up here so you don't miss it. I'm going to go through the first round of it for you, okay? And then then you'll have time to write it down. The first thing you're going to do is take the first coefficient, and it's going to drop down here, and you're just going to write it, a 1, okay? Next, you'll take that negative 2, that's the 0, multiply it by the 1, and you're going to write it here. So it's going to be negative 2 times 1, which is negative 2, which is going to go here. And then this vertical column right here, you're just going to add those things. So 3 and negative 2 is 1. And then the whole thing repeats all the way down. Okay, so go ahead and write that down before I finish the rest of the problem for you. So just like in long division, we got to that point in each problem where I said, okay, this is where it repeats itself. This is the point in synthetic division where it just repeats itself. I take this -2 times that 1, write it here. I add vertically. -4, -2 is -6. And I put that down here. Then I take that -2 from the divisor again, times that -6, that's +12, it goes here. And then I add vertically and I get 0. What's similar about this 0 and the 0 we got in the warm-up? What do you think this is? That's the remainder. So whenever you're doing synthetic division, this very last piece is always going to be your remainder. Okay. But this isn't our final answer. Okay, this is just the work. Our final answer still has to look like the quotient plus the remainder over the divisor, and we're going to put all those x's back in there. So here's the process for that. Your first term, when you go to write your answer, let's look at the warm-up real fast. Don't look at the 2's. The problem started with a degree of 3, and the answer started with a degree of what? What do you think that pattern is? Something that we can use for even other problems. How do we go from 3 to 2? How is it changing, 3 to 2? It's subtracting 1. Okay, it's subtracted by 1. So even if the degree that we started with was to the 5th, our answer would start with the 4th, and so on, because we're really dividing by a linear divisor. We're dividing 1 by 1x. And so when we go back to this problem, when we have to add our x's back in, you have to understand that this first term represents x to a degree that's 1 less than we started with. So we started with 3. Our answer is going to start with squared. Then that next term is x to the 1, and the next term is x to the 0, which we don't have to worry about because that's really just 1. So then we just smush all that together, the coefficients with the x squareds, and our final answer is 1x squared, okay, plus 1x minus 6, and then a remainder of 0, which you can write over the divisor or not. I don't care either way. Okay, and that's exactly what we got with the long division. Right. So you try that next problem, please. What number will you be putting in the little box? -5. Very good. Whatever makes the root, or whatever makes the divisor equal to 0. We put the 0 for the divisor in a little box. Good. And then we write the coefficients next to that, right? 3, 13, -10. We put some space underneath there because we're going to fill that space with stuff. And then we put a line. And don't remember. Don't forget that we'll be adding vertically as we go along. Some people like to put that plus there to remind themselves for that. So what's the first thing I'm going to do? Bring down this 3, right? I don't have anything to add to it just yet because I haven't really done anything. So I bring this 3 down, and now I do the -5 times that 3, and write it here is -15. Adding vertically gives me -2. So -5 times that -2 is +10, and that gives me a remainder of 0. So when I go to add my x's back in, I'm starting with a degree of what? 1, right? A degree of 1. Because I started with degree of 2, so now my answer will start with degree of 1. So that's x to the 1. That's x to the 0, which we don't need to talk about. We don't talk about at parties. 3x minus 2 with a remainder of nothing. Okay? So really, if you got that wrong, it's probably just because of not understanding the setup somehow, which will come to you with practice, okay, once you do a few. All right, so these 2 problems that we did, notice that they were titled No Missing Terms. The next 2 will have missing terms. Now, yesterday when we did long division, there were some missing terms, and I told you to do what? Use 0 as a placeholder. Now, that was optional yesterday. If you felt comfortable doing that with, or not doing that for long division, it's still workable. You would just have to leave yourself some empty space in the problem. However, today it's an emergency. So on synthetic division, though, you absolutely positively have to use 0 as a placeholder. It's going to mess your stuff up. All right. So in this particular one, looking at the dividend, which term is missing? X squared. So we really have a 0x squared going on right there. So when I set up my long division, or synthetic, what's going in the little box? Positive 3, very good. And then I write my coefficients. My coefficients are 2, 0, 3, and 7. And then you give yourself some space under there. You draw your bar that represents that you're going to be adding. What's your first step after that? Bring down the 2. Okay. 3 times 2 is 6. That goes here. You add. That brings down 6, and you go ahead and finish out the problem. I think I got any of that. I'm messing up the recording today. Plus 21 plus 70 over x minus 3. Okay, who ninja'd to that problem? All right, perfect. So the next problem, in case you skipped ahead a little bit and you tried the next problem, let's make sure you got set up correctly, because I'm going to write up here the most common mistake I've seen all day with the next problem, and I want you to figure out where it's wrong. Okay, just on the setup. What's wrong? There should be a 0 where? After where the x squared is, right? Between the 1 and the negative 9. So I'm not exactly sure why people have been missing that all day, but they have. They get these 2 zeros correct and then don't notice that it's missing an x term right there. So there should be a 0 right here. Okay, so take a minute and do the synthetic division on that. Okay, if you're still finishing, go ahead. I'm going to put my work up here so those who are done can check their work, and then as you finish, you can check your work. So your final answer is 2x to the 5th minus 6x to the 4th. 0x cubed, I'm not going to write that, that's just nothing. 0x squared is nothing. I have 1x to the 1, so that's just x. And then minus 3x to the zeros, which is, we don't have to write that. Okay, who got that? All right, very good.